right, let's take a look at today's do now. We have if f of x is equal to 2x squared minus 4x plus 1 and m of x is equal to 5x minus 2, we want to find a f divided by m, in which my input is 2x plus 1, and b f plus twice m when our input is 3n minus 2. So pause the video, try these two questions on your own, and we will compare our answers. All right, so for part A, after substituting our input of 2n plus 1 into the f and the m function, we end up with a final result of 8x squared minus 1 over 10x plus 3. For question B, when we input 3n minus 2 into the f and the m function, not forgetting to double the m function, doing our distribution, combining like terms, we should end up with 18n squared minus 6n minus 7. So let's take a look at today's thinking. How do we perform a composition of functions? So composition of functions, given functions f and function g, we are inputting one function into another. So we have to substitute one function into another. The notation that we are going to be working with, we have f parentheses and our inner function of g of x. This is read as f composed of g of x. We could have our notation as f, a little open circle, which means composition or composed of g of x. So when you are given questions like this, you have to identify what you are starting with. And you are always going to start with the innermost function or the function that is closest to the input. So in this case, we start with the g of x function. And we need to evaluate g of x. So when we evaluate, we input something into the function and we end up getting an output. That output now becomes the input for the next function. And the process continues the more functions you have been composing. So the second one, very similar but slightly different. We have g parentheses, inner function would be f of x, so g composed of f of x. Or we have g, this open circle, which again means composed of f of x. As we said, what you are going to be working with is the innermost function or the function that is closest to the input. You start with that function. We evaluate this function. That's going to give us some sort of output. Now that output becomes the input for the other function. So in this case, the g function. And the process continues the more functions you have. So let's try doing our composition process. Example, perform the composition of functions. For number 1, we have a function d of x, which is x plus 5, and g of x, which is 4x minus 3. We have to find d, little circle, open circle, which means composed, of g of input 3. So what we are going to do is identify the input, and the function that is closest to it is what we are starting with. We're going to evaluate g of 3. We get an output of 9. This is the now input for the following function. So the d function says x plus 5, in this case the now new input, plus 5, which we would have a result of 14. Let's look at question number 2. We have the d function, which is x plus 5, and the g function, which is 4x minus 3. We have find d parentheses of g of 2n. Again, we have a function and another function within. So we are dealing with a composition. D composed of g of 2n. We are always going to be working with the innermost function or the function that is closest to the input. So in this case, we're starting with the g function and inputting 2n. We're going to evaluate that. In this case, we get an output that's algebraic, but this output is what's going to be our input for the next function. And again, we are going to evaluate this input into the d function and get our final result to be 8n plus 2. So 2 things to note. When we have a numeric input, we're going to have a numeric output. When we have an algebraic input, we will always have an algebraic output. Let's look at number 3 and number 4. We have if f of x is equal to x plus 1 and g of x is equal to 2x, find g composed of f of input a plus 3. So we are going to start with the innermost function, which is my f function. Take this input and input it into the f function. We get an output of a plus 4. This output is now the input for the next function, which is the g function. And we're going to do the evaluation again on here. And we end up with 2a plus 8. For number 4, same 2 functions. We have the f function and the g function. We have f composed of g of 2x plus 3y. We identify the function we have to start with, get an output. That output becomes the next process. So I'm going to let you guys try this one out. All right, so we start off with the g function. We input this 2x plus 3y, evaluate, get an output of 4x plus 6y. That now becomes the input for the f function, giving us a final output of 4x plus 6y plus 1. And last question here, number 5. We have if f of x is equal to x plus 1 and g of x is equal to x squared minus 2x, find g composed of f of x squared plus 4. So we are starting with the innermost function, again, the function that is closest to the input, which in this case would be f. We're going to take that input and put it into the f function. We get an output of x squared plus 5. That now becomes the input for the g function. And we're going to evaluate all over again. So we have x squared plus 5, and we're squaring that, minus 2 times that input. And here we're just going to clean this up by doing our algebra. And we get our final output to be x to the 4th plus 8x squared plus 15. So keep learning, keep growing, and I will see you in our next video.